Okay, so welcome to my channel and welcome to the series of videos of managerial economics. And in this particular series, I've been teaching on game theory. So in this particular video, I'll be continuing with the application of one-shot simultaneous games. So please, if you have not subscribed to the channel, please do comment, share, and let us have your feedback. But most importantly, subscribe to the channel. Now, if you have also not watched the part 1 of the series on game theory, please do so because we are going to apply what we've learned in those series, and then we are going to apply them to this particular video. So try and look for the video on introduction to game theory so that you understand this particular video. Now, we are going to learn application of one-shot simultaneous games to pricing decisions. Now, one of the things you must know is that managers can apply, or we can apply the concept of one-shot simultaneous games to even our pricing decisions, okay? So let's look at how game theory can help us formalize optimal decision-making in a Bertrand duopoly. Remember, Bertrand duopoly is about price war or competition of prices to get the larger share of the market. So here, two managers want to maximize market share, and thus the expected payoff for this scenario will be the percentage of market share that they will get at the end of the day. And of course, the strategies are their pricing. So here we have 3 strategies. We have to set 1 Ghana cedi as a price, to set 5 Ghana cedis, and to set 10 Ghana cedis. Those are the strategies for player 1. And then we also have strategies for player 2 to set 1 Ghana cedis, 5 Ghana cedis, and 10 Ghana cedis price. And then the game is a one-shot simultaneous move game. Now here, this is the normal form of the game. So in this normal form, what it means is that if player 1 plays 10 cedis and player 2 plays 10 cedis, player 1 will get 50% of market share, player 2 also get 50% of the market share. If player 1 plays 10 cedis and player 2 plays 5 cedis, player 1 will get 2 cedis market share, 20% market share, and player 2 will get 80% market share. Okay, so that is that. Then also, let's pick some others and explain. Also, if player 1 plays 1 cedi, player 2 plays 1 cedi, player 1 will get 50% of the market share. Player 2 also get 50% of the market share. So we are going to do some analysis of this normal form game. Now, let's first of all examine the dominant strategy in this normal form game, the dominant strategies. Remember that the dominant strategy is the strategy that will yield the highest payoff to a player, no matter what the other player or no matter what his opponent will play. So here, looking at this table, if player 2 plays 10 cedis, okay, the best response of player 1 should be within this column. So the best response of player 1 is also to play, the best response of player 1 is to play 1 cedi because 90% market share is better than 80% and is better than 50%. Also, if player 2 plays 5 cedis, that means the outcomes will be in this column. The best response for player 1 is to still play 1 cedi because 80% of the market share is better than 50% and is better than 20%. Finally, if player 2 plays 1 cedi, okay, the response should be in this column. And then, the outcome should be in this column. And then the response of player 1 will still be 1 cedi because 50% is better than 20% and is better than 10% market share, okay? So looking at this, what it means is that if player 2 plays whatever he wants to play, player 1 is better off by playing 1 cedi, okay? So it means that the dominant strategy for player 1 is equal to 1 cedi, is to play 1 cedi. Now let's examine the dominant strategy for player 2. Dominant strategy for player 2. Now, to examine the dominant strategy of player 2, we would examine the strategies that will be employed by player 1 and then the best response of player 2. Okay, so now if player 1 plays 10 cedis here, okay, then the outcomes will be in the horizontal situation, okay? So if player 1 plays 10 cedis, the best response for player 2 is to play 1 cedi, because here we see that 90% market share is better than 80% and is better than 50%. Again, if player 1 plays 5 cedis, that means that the outcome should be in this row or this this horizontal row. Now here, what we will see here is that if player 1 plays 5 cedis, the best response for player 2 is still to play 1 cedi, because 80% market share is better than 50% and is better than 20%. Finally, given that player 1 plays 1 cedi, the outcomes should be in this row, okay? Again, the best response for player 2 is to play 1 cedi, because 50% market share is better than 20% and is better than 10%. So the dominant strategy for player 2 is also to play 1 cedi, all right? So the dominant strategy for both players is to play 1 cedi, 1 cedi. And then where the dominant and dominant will meet, the outcome will be the Nash equilibrium. So here, the dominant strategy for both players is to set the price at 1 cedi. There is no pure secure strategy because they both have a dominant strategy. And then the Nash equilibrium is when the two of them, they play their dominant, which is to play 1 cedi, 1 cedi. And then the outcome or the payoff of the Nash equilibrium is 50% market share, 50% market share for both. Now, somebody may be wondering, why is it that they don't set 10 cedis, 10 cedis? Because that would have benefited them and still gotten the market share of 50%, 50%. Now, 10 cedis is not a Nash equilibrium, because when one person moves from that, holding the other person constant, the one who moved will increase his payoff. Let's examine this situation. Now let's examine that let's assume that they play 10 cedis, 10 cedis. So they are here, okay? Now, holding player 1 at 10 cedis, if player 2 moves to 5 cedis, player 2 will increase his payoff from 0.5 to 0.8, okay? So here, it is not a Nash. Remember, Nash equilibrium says that you will not increase your payoff if you move alone. But here, given that player 2 moves alone, he will increase his payoff. Even at 10-10 at strategy 10 cedis, 10 cedis, you also realize that given that we hold player 2 here and player 1 moves alone, player 1 will also increase his payoff from 50% to 80%. So that is not a Nash equilibrium. For a Nash equilibrium, if you move alone, you decrease your payoff, all right? We can even examine that Nash equilibrium, which is here. So here, if all of them are at 1 cedi, 1 cedi, and let's assume player 1 wants to move to 5 cedis, he will increase his payoff from 0.5 to 0.2. So it's a Nash. For Nash, once the two of you move, once each of you or once one of you move, holding the other person constant, you will decrease your payoff, all right? Let's also check that for player 2. If player 2 is here, holding player 1 at 1 cedi, if player 2 decides to move to 5 cedis, he will increase his payoff from 0.5 to 0.2, so he will not move. And that also proves why this point is the Nash equilibrium. At a Nash equilibrium, if one person moves, if one person moves holding the other person constant, he will decrease his payoff. And that sense should exist for both of them, all right? That condition should hold for both of them for that place to be a Nash equilibrium, okay? Let's also apply it to further pricing decisions. Let's look at this example. firm Ashasi and Ewieye serve the same market. They have a constant average cost of 2 cedis per unit. So remember, their average cost is 2 cedis per unit. The firms can either choose a high price or a low price for the output. When both firms set a high price, total demand is 10,000 units, which is split evenly between the two firms. So when both set a high price, listen carefully, the total demand will be 10,000 units, which is split evenly between the two firms. That means that each of the firm will get 5,000 units. When both set low price, the total demand is 18,000 units, which is again split between the two of them. So it means that when they both set a low price, okay, all of them will get 9,000 units each. Now, if one firm sets a low price and the second firm sets a high price, the one that sets the low price will get 15,000 units. The one that set a high price will get 2,000 units. So the requirement is that we should analyze the pricing decisions of the two firms as a non-cooperative game. That means that each of them is seeking their own interest. Now, in a normal form representation, construct the payoff matrix where the elements of each cell of the matrices are the two firms, their profit. B, determine the dominant strategy of each firm. C, determine the secure strategy of each firm. D, determine the Nash equilibrium, and then the payoff at the Nash equilibrium, right? So you're going to solve this question. Now, remember that, first of all, let's set some things straight. The question says that each of the firm operates at a constant average cost of 5 cedis. Remember that average cost is equal to total cost divided by quantity, okay? Average cost is equal to total cost divided by quantity, all right? Which means that total cost is equal to average cost times quantity. And I think we learned this in our lessons on production and cost, okay? Now, also remember that total revenue is equal to price times quantity. Now, profit is equal to total revenue minus total cost, which is PQ minus ACQ, okay? If you factorize the quantity out, profit is equal to price minus average cost, okay? And I'm doing this for us to get a shortcut for the profit. If you don't understand what I'm doing, you can just do the normal total revenue minus total cost. You still get the same profit, okay? You can just do the normal total revenue minus total cost. You still get the same profit. Okay, so here, the question says that if they set high, okay, all of them will get 5,000 units each, okay? So the total revenue for the firm one will be the price, which is the high price of 10 cedis, times the quantity of 5,000 units. And this will give us 50,000 cedis. Then the total cost will be the average cost of 5 times the number of units, and that will give us okay, so the average cost actually is 2 cedis from the question, okay? Sorry. So this will give us 10,000 cedis. So the profit will be total revenue, which is 50,000, minus total cost, which is 10,000. So this will give us 40,000 cedis, okay? We could have alternatively used this formula. So profit is equal to the quantity, which is 5,000 into bracket. So we could have used this formula. into bracket the price, which is 10, minus average cost 2. All right. When you do this, you get 40,000 straightforward. Okay. Now, the profit for the second firm is also based on 5,000 units. So here, the profit for the second firm will also be 5,000 units into brackets. The price, 10 minus 2, we also get 40,000, okay? So when they set high price, this will be their profit. Now let's look at a situation where they set low and low, all right? So firm 1 sets low, firm 2 sets low. Now the question says, when the two of them set low prices, they will get an output of 18,000, which will be split evenly between them. That means that each of them will get an output of 9,000 units, okay? So each of them will get an output of 9,000 units. So let's look at their profit. So profit for firm 1 will be equal to the output. Remember the formula. Output, which is 9,000 into bracket the price. So we are dealing with the low price now, not the high price. In the question, the high price is 10 cedis. The low price is 5 cedis. So when they set a high price, they are setting it at 10 cedis. When they set a low price, they are setting it at 5 cedis. Okay. So here, if you look at the question that is here, the question here says that they can either choose a high price, 10 cedis, or a low price, 5 cedis. So remember that. Anytime they are setting a high price, it's 10 cedis. When they are setting a low price, it's 5 cedis. So we have the output into bracket, the price, 5 cedis minus the average cost, okay? So when you solve it, you get 27,000. Then also profit for firm 2, he's also getting 9,000 units. Into bracket the price, the low price, 5 cedis minus 2, you also get 27,000. Okay, so this will be the outcome when they set low price. Now the question says that if one sets low and the other sets high, the one that sets the low price will get output of 15,000. And the one that sets a high price will get output of 2,000. So let's deal with low and high. So low and high, let's assume firm 1 sets low. So he will get an output of 15,000. So output into bracket price. The low price is 5 cedis minus average cost 2, you get 45,000. Then let's assume firm 2 is the one that sets the high price. So he will get the output of 2,000 into bracket. The high price is 10 cedis minus average cost of 2. That will be 16,000, okay? Now let's finally end with high and low. High and low. So here, we can clearly see that if M1 set high, he will now be the one who will get the output of 2,000, okay? To bracket 10, which is the high price minus average cost of 2, which will be 16,000. Then the one that says low price firm 2 will be 15,000. Output into bracket the price 5 cedis minus 2, so you get the profit of 45,000, okay? So all these are the outcomes. So now let's go and draw our normal form table. One of the things I want you to know is that if you are not getting the shortcut for calculating the profit in this particular scenario, just do your regular total revenue minus total cost based on the required output and then the required price and average cost, okay? You'll get the same answers. Now, let's draw our normal form. So in our normal form, we have the low price, we have the high price, okay? Then we have the low price and then the high price here again, okay? So when both set low price and low price, remember, the two of them will get 27,000 profit each, okay? Okay, And when both set a high price, they will get 40,000 each. Profit. Now, when one set low and one set high, the one that sets low will get 45,000. The one that sets high will get 16. So let's assume firm one sets low, firm two sets high. So we have 45,000 and then 16,000. Then the vice versa. If firm one rather sets high, so let's name here firm one, okay? And let's name here firm two. So if firm one says high, he will now get the 16,000, and then firm two will get, the one that says low will get the 45,000, okay? All right, so let's examine their dominant strategy. Okay, so here, we will hold firm two at low, okay? If we hold firm two at low, the best response for firm one is low because 27,000 is better than 16,000. So the best response when firm two chooses low is for firm one to choose low, because 27,000 is better than 16,000. Now, if firm two, assuming firm two plays high, okay, the best response for firm one is still to play low because 45,000 is better than 40,000, all right? So here, no matter what firm two plays, firm one is better off playing low. So the dominant strategy for firm one is to play low. Okay, now let's look at the other way around. If we hold firm one at low, okay, that means we are choosing on this particular row. Okay, the best response for firm two is to play low because 27,000 is better than 16,000. Okay, if you also hold firm one at high, still the best response for firm two is still to play low because 45,000 is better than 40,000. So no matter what firm one plays, firm two is better off playing low. That means that the dominant strategy for firm two also is low. All right. Now, because both of them have a dominant strategy, none of them has a secure strategy, okay? And then the Nash equilibrium in this scenario, so let's look at the question. The question says, the normal form we are done, the dominant strategy we are done. There is no pure secure strategy for the two of them because all of them have a dominant strategy. Then determine the Nash equilibrium. So the Nash equilibrium will be for the both of them to play low, low, all right? That will be the Nash equilibrium. And then the outcome of the Nash equilibrium is 27,000 for each, 27,000, okay? All right, so remember that Nash equilibrium is the meeting point for dominant and dominant strategy when both of them have a dominant, okay? So we are done with that. Let's finally end the application. In this first round of application, let's end on advertising and quality decisions. In the next video, I'll teach on application to output decisions, okay? Now, suppose your firm competes against another firm for customers. You and your rival know your products will be obsolete at the end of the year and must simultaneously, so that makes it a simultaneous move game, must simultaneously determine whether or not to advertise. In your industry, advertising does not increase total industry demand, but instead induces consumers to switch among the products of different firms. Thus, if both you and your rival advertise, the two advertising campaigns will simply offset each other, and you will each earn 4 million in profit. Okay, you each earn 4 million in profit. Now, if neither of you advertise, that means no advertisement and no advertisement, each of you will earn 10 million in profit. However, if one of you advertise and the other one does not, the one that advertised will earn 20 million and the one that does not will earn 1 million. So if one of you advertise and the other does not, the one that advertised will earn 20 million and then the one that does not will earn 10 million. Okay. Represent the above scenario in a normal form game. What is the dominant strategy for each firm? What is the secure strategy for each firm? What is the Nash equilibrium? So here we can clearly see that if both advertise, okay, all of them will get 4 million, 4 million. If both don't advertise, that's here and here, each of them will get 10 million, 10 million. If one advertises and one does not, so on the assumption that firm A advertises and firm B does not, firm A will get 20, firm B will get 1. On the assumption that firm A does not, but firm B does, firm A will get 1, firm B will get 20. So that is the representation of the normal form game. Now let's look at the dominant strategy. The dominant strategy is the strategy that will benefit or that will yield the highest payoff no matter what the opponent will play. So let's say we are firm A. Let's assume firm B plays advertise. The best response for firm A is to play advertise because $4 is better than, 4 million here is better than 1 million. Now, if firm B plays don't advertise, the best response still for firm A is to advertise because 20 million is better than 10 million, okay? So no matter what firm B plays, firm A is better off advertising. That means that the dominant strategy for firm A is to advertise. Now let's look at firm B. So to check that for firm B, we will examine the situation by holding firm A at their strategies. So if we hold firm A at advertise, the best response for firm B is to advertise because $4 is better than, 4 million is better than 1 million. Then if we hold firm A at don't advertise, firm B is better off still advertising because 20 million is better than 10 million, all right? 20 is better than 10 and 4 is better than 10. 4 is better than 1. So it means that the dominant strategy for firm B also is to advertise. Now, when those dominant strategies meet, then we will have the Nash equilibrium, right? So the Nash equilibrium is to advertise and advertise. Okay. All right. Now, yes. So now we realize that, of course, if the two of them coordinated or agreed to play don't advertise and don't advertise, you realize that they would have been better off because they would have gotten 10-10, right? So in the next video, I'll teach on coordination decisions. I'll teach on when it is possible for players in a one-shot simultaneous game, when it is possible for them to coordinate. Because here, if they had coordinated to play don't advertise and don't advertise, they would have been better off because they would have gotten 10 million, 10 million, right? So please kindly subscribe to the channel, share, comment, and let us have your feedback. Let's look at further examples in the other videos. So in the next video will be part 3 of my series on game theory. Okay, thank you.